Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. So, I am your chemistry faculty S. So, we are dealing with the 9th class chemistry and we are doing now the thermodynamics chapter in that second synopsis, like second unit. Right students? So, in the second unit already we have started and we have completed few topics. So, what we have completed that once once revise and then we go to the new topics. So, see students here in this synopsis 2 we were discussing about internal energy, heat, work done and okay, these are the important terms we discussed, and along with that we discussed the zeroth law and first law. So, zeroth law of thermodynamics, what it says is, if two systems are in thermal equilibrium with the third system, for example, this is one system, this A, this is B, and these two are in thermal equilibrium with the third system, let this is a third system, then we can say that A and B are in thermal equilibrium, right? If two systems are in thermal equilibrium with the third system, they are also thermal equilibrium with each other. This is a thermodynamic zeroth law. Okay. Then we studied about the first law. What the first law explains? The net energy. Okay. The net energy in a closed system is equal to the heat absorbed plus work done by the system. This is the first law of thermodynamics, what it says in chemistry, the net energy in a closed system is equal to heat absorbed and work done by the system. Okay, this already we discussed. So, here net energy is equal to, this is a Q stands for heat absorbed and W is a work done, right? This already we discussed, like, okay. Now, then today what we are going to discuss? So, today we are going to discuss about the enthalpy and heat content, very important topic. So, see students, here this is a IIT Foundation and we are giving IIT Foundation for your 9th class students. Okay. So, here in this thermodynamics, so many new terminologies you come across, and these terminologies you might have not heard or not come across during your school syllabus. Okay. So, this is little beyond from your textbook. So, that is what a new terminology will come and you need to understand that new terminology, what is that terminology and what is it meaning, right. So, today we are going to discuss about the heat content, okay, that is nothing but an enthalpy. So, enthalpy, so it looks, the word look like a new word, okay, so it does not look like an English word, no, but okay, this is enthalpy. And the meaning of this one is nothing but a heat content, okay. So, heat, you know, content how much, okay, that is called a heat content. So, heat content is called the enthalpy, right. So, what is the enthalpy? Very easy. So, try to understand this one. Heat content is equal to the heat absorbed or evolved at a constant temperature, at a constant pressure. Okay. So, there is a simple logic, right. Heat content of the system is what is equal to the heat absorbed or heat evolved at a constant pressure. So, see students, here in this thermodynamics, mostly we are discussing about the gases. We are discussing about what? The gases, right. So, when you take the gas, normally, for example, if you take the solid, okay, it do not have much effect of the pressure, okay. So, this is solid, you see this is the shape of this one, and now I am applying some pressure on it, see, lot of force I am applying, but there is no change in it, right. Now, for example, I am taking the mobile is there, and this is a mobile, and I am pressing it, but there is no much effect of the pressure on this mobile, right. So, generally in the solids and even in the liquids also, there is no much more effect of the pressure. But in this chapter we are discussing mainly the thermodynamics. We discuss about mainly about the gases. Means I said you the system. System is what the study on which we are doing, that is called the system. So here our system is one closed vessel. This is a closed vessel, and in this air is enclosed. Air is means gas is enclosed, not air. Some gas is enclosed. So some gas is there. Okay, this is a gas. Okay, and it is covered with one piston. Okay, so this is called a piston. What it is called? A piston. Okay, like this it's kept with the piston. So this is our system. So the thermodynamics, in almost total thermodynamics, we are going to 90% of our intention. Okay, we are going to discuss about the gases only, and that gas is enclosed one cylinder. So this is a cylinder along with one piston. So this is a piston. You know piston, I think. Okay, piston, and in that the gas is enclosed. That is our system. Okay, throughout this chapter. So remember that one. So here what it says, heat content of the system is equal to the heat absorbed or evolved at a constant pressure. At constant pressure. So the meaning is what? Pressure should be kept constant. Means what? For example, if you are this is a cylinder, and on this some gas is there. On that we are keeping some this is a piston, and the piston we keep some weights on it. Okay, so we keep some weights on it like this. Okay, so this weights I am putting here. This weights. So this weights exerting some pressure. These weights are exerting some pressure, right? So because weight exerts a pressure, right? So weights are exerting some pressure on it, right? And this we are not going to change. We are not going to change that pressure. So meaning is what? Pressure is kept constant. Pressure is constant. Constant means what? It's same throughout our experiment. Okay. Now in such conditions, now what is the heat absorbed? Okay. What is the heat absorbed? Okay. Or what is the heat released? Evolved means what? Released by the system. Then that is called enthalpy. Is this clear to you? Okay. In simple way, heat is absorbing or heat is releasing. Okay. So amount of heat is absorbed, the amount of heat liberated. So that is called enthalpy. But small scientifically what we say that at a constant pressure. This is the only new thing. Clear to you? So heat absorbed or heat evolved. Evolved means what? Released, giving. Okay. So absorbing of heat or releasing of heat is called enthalpy. That's all. But here we are using one word called at constant pressure. That's all, students. That's a very simple definition. Okay. So don't feel this is new to you. So heat content, that's enthalpy. Instead of enthalpy, so heat content also we can say. So enthalpy, if I want to ask you what's the definition of enthalpy, you can say that enthalpy is nothing but a heat content, and the heat content, okay, heat content of the system is equal to the heat absorbed or evolved at a constant pressure. Okay. So here this delta H, okay, del H we can say here, what is called del H. So this del H is equal to the heat. Q stands for what? Heat absorbed or heat released. Heat absorbed or heat released at a constant pressure. That's all. This is called enthalpy or heat content. Clear? Any doubt? No. So now what is the heat content enthalpy? We written this formula here, simple formula, that delta H is equal to QP. Okay, in terms of definition. Is there any other formula? So students, there are so many formulas we can derive from this one. But the thing is that here as you are in 9th class, okay, here we are not going to, and this as a IIT foundation, we are not going to derivation part. You know the derivation. So derivation means what? How that equations can be derived, because that is not necessary to us. Okay. So in the IIT JEE mains, mainly they ask about the multiple choice questions to you. Okay, mostly multiple choice questions. So that's what it not required the derivations. So and for your standard, the derivations are not necessary. Okay. So I'm excluding the derivations which are not useful to you. I am going to directly write the formulas and I will explain you what are those formulas represent, right. So, now see here, so how it can be calculated. So, here absolute enthalpy cannot be calculated. Student, remember it's very important point. So, absolute enthalpy, absolute heat content cannot be calculated. It is not possible. Okay. So, then what we can calculate? So, we can calculate, it can be calculated as the sum of the internal energy, and the product of pressure and volume. Okay, sum of the internal energy and the product of pressure and volume. So, here internal energy is denoted by what? Delta E. Already in the first law we discussed. Okay, internal energy is denoted by what? Delta E. Now, product of pressure and volume. Pressure means what? P. Volume is what? V. What is the product? Product means what? Multiplication. Product means what? Multiplication. So, the product of pressure and volume. Okay. So, here product of this one is what we can write as a PV, but we should not take PV here. Why? Because when you maintain the constant pressure, when you want to maintain the constant pressure, and there will be a change in the volume. There will be a change in the volume. When you maintain the pressure constant, so there will be a change in the volume. So, if you write a V, V looks like constant. Okay. If you write delta V, there is change in the volume, maybe increase, maybe decrease. So, there is a change in the volume. So, here we can write the PV as P del V. Okay, P del V. Del V represents what? The change. Del represents what? The change. So, change in the volume. Now, see here. The sum means what? Addition of internal energy. So, see here, internal energy is delta A. Sum means what? Plus, and the product means what? Multiplication of pressure and volume. So, that is P delta V. Okay. This is heat content. Okay. So, these are the heat content formula. Clear to you? Any doubt? So, content can be calculated, enthalpy can be calculated as what? Sum of the internal energy plus the product of the pressure and the volume. So, sum means what? Addition of internal energy is denoted by delta E. Okay. And the product of pressure and volume. Product means what? Multiplication. Pressure and volume. So, PV. Now, this both we are adding. So, then we can get del E plus P del V is equal to the heat content. So, in this way, we can calculate the heat content, students. Is this clear? Okay. So, how it can be derived? I said, so there are derivations is there, but we are not going to deal with the derivations, right? So, this is very beyond of your knowledge. So, that's what we are going to only the formulas, right? Now, so now what about the heat content? So, whether heat content is always positive or always negative, means what? Heat content maybe increases or maybe decreases, so always it remains same. So, students, here heat content means enthalpy does not remain same for all the reactions. Okay, it will be different for the different reactions, right? So, already we discussed in the previous classes somewhere about the exothermic reactions and endothermic reactions. Did you remember? Exothermic, endothermic. Yes. So, exothermic means what? A reaction in which heat is released, in which heat is evolved. Okay. So, in which heat is liberated. Such reactions are called exothermic reaction. Okay. Exo, exit, EX. Okay. Exit, EX. Okay. So, like it is releasing. Exit means what? Going away. Okay. So, the reaction in which heat is releasing, heat is going away from the reactants. So, such reactions are called exothermic reactions. Clear? And similarly, the reactions in which heat is absorbed, okay, such reactions are called endothermic. Endo, entrance. Entrance means what? N-E-N, entrance means coming inside, right? So, here heat coming into the reactants. When the heat comes into the reactants, the reaction will be taking place. So, the reaction which takes place in presence of heat or by observing the heat, okay. So, such reactions are called endothermic. And the reactions in which heat is liberated, released, going away out of this reactants during the formation of product are called a exothermic reaction. Clear? So there are two types of reactions are there. Now let us see what are these. Okay, so here exothermic reaction. So exothermic reaction means what? The reactions in which heat is liberated. Heat is liberated. Heat is liberating, okay, means what? Now whatever the products form, those heat content is less than the heat content of the reactant. Yes or no? Okay. For example, let's take one example here. So here you can see here, nitrogen is combining with a hydrogen to form ammonia. This you know, okay. So this already, you know, this reactions already we discussed, okay. Nitrogen reacting with hydrogen to form ammonia. But during the formation of ammonia, so see here, it is releasing 92 kilojoules of energy. How much energy it's releasing? 92 kilojoules of energy is releasing. Means what? The heat is coming away. Heat is coming away. Okay. So we are taking the nitrogen, we are taking the hydrogen, we are mixing. So of course they are forming the ammonia. Whereas ammonia is forming, from that heat is going away. Okay, and we are getting one product called ammonia. Is this clear to you? So now here if you see, if you add these both, okay, energies, energy heat content of the reactants, okay, when you compare with the product, okay, heat content of the product plus this both is equal to this one, okay, the total heat is equal of this one is equal to total content, heat content of this one. Yes or no? Now here what's happening? Here this total content is should be equal to this one, but here it is releasing, it's going away. So then what happens? Now here heat content of ammonia, if you check, it will be less only. It will be less. Okay. So the meaning is what? Here the heat content of the reactants is greater than the product. Heat content of the product, or we can say that the heat content of the product is less than the heat content of the reactants. Clear to you? So here which reaction this is? This is an exothermic reaction. Which reaction this is? Exothermic reaction. Exothermic reaction means what? In which heat is liberated when the reaction is taking place. So heat is liberated. And other one is here carbon. React with oxygen to form the carbon dioxide, and here it is heat released is 393.5 kilojoules. Right. So when you are burning the carbon, okay, in presence of oxygen, so carbon burns in oxygen, okay, and forms the carbon dioxide along with the heat is released. Yes or no? So from that heat is going away. Heat is releasing means what? From the carbon dioxide, the heat is going away. When the heat is going away means what? The heat quantity in the carbon dioxide is less than the heat content of the carbon and oxygen. Right? So these are called reactants. These are called what? These are called reactants. Okay. And these are called what? Products. Okay. These are called products. So here when the reactants are reacting, it's forming the product and it's going, some heat is going away. So some heat is going away means what? The heat content of this one is greater than the product. That's all. Did you understand the concept? Okay. For example, you see, I'll tell just your normal language. For example, I've taken, I've taken some 2 red balls I have taken, okay, 2 red balls I have taken, and 3 black balls, okay, 3 black balls I have taken in one bag, for example. Just imagine, okay, then some of the balls are taken away. So see, some of the balls are taken away, okay. Now, means for example, 1 or 2 balls are taken away. Now left with what? Left with only 3 balls. Yes or no? So this 3 is less than this one. Yes or no? Right? So in that way you think. Okay. So the heat content of the reactants, when the reactants are combining to form a product in the exothermic reaction, some of the heat get released. So the heat content of the product is less than the heat content of the reactants. Okay. So how can we write mathematically? Mathematically we can write that heat content, sorry, here written wrong. Okay. Okay, if I write heat content of product minus this one, so I will get minus only. Chalo, see here. So here, so heat content of the product is less than the heat content of the reactant. Okay. So now this is smaller, this is bigger, right? So now delta H, how much heat content? Okay, enthalpy change. So that we can write the HP minus HR, means product minus reactant. So product is less and reactant is greater. From less we are subtracting the greater one. So what will get here answer? Negative. So therefore heat content is negative for the exothermic reactions. Clear to you? Okay. So here the heat content of the products is less than the heat content of the reactants. So how much change in the heat content? What? How can you say the heat content of the product minus heat content of the reactant? But the heat content of the product is less than the reactant. Means this is smaller than this one, and this is greater. It has a negative sign. Okay. So what will get the answer? That will be what? Negative. Is this clear to you? So therefore delta H is equals to negative for which type of reactions? For exothermic reactions. Now for endothermic reactions or what? Endothermic means what? Heat absorbs by taking the heat. Okay, the reaction will takes place, right? So see now, these are okay, these are endothermic reactions. In endothermic reactions, what happens? They takes the heat. Okay, so by taking the heat, the reaction will be taking place. So here is taken the heat and the reaction is taking place. Is this clear to you? So here, then what happens? The heat of the heat content of the product is greater than the heat content of the reactant. Clear? So now difference in the heat content is what? Delta H. That's called enthalpy. So enthalpy is equal to product minus reactant. But here the product is greater. Product is greater than the reactant. So product is greater than the reactant. So here smaller one we are removing from the higher one. So then what will get the answer? That will be in positive. So therefore enthalpy, okay, the change in the heat content, that's called enthalpy, is positive. In which reactions it is positive? In endothermic reactions it is positive. In exothermic reactions it is negative. Clear? Right. Now for endothermic reactions, we can give some examples. Like you see a nitrogen plus oxygen formed to nitrogen oxide. So here there is a heat absorbed. See, a minus is written, means what it is? Heat is absorbed. Heat absorbed is 180.8 kilojoules. Similarly, carbon is combining with the sulfur to form the carbon disulfide, and here also a minus is given. The meaning is what? It is absorbing the heat here. Okay. So these are called endothermic reactions. So in endothermic reactions, the heat of the product is greater than the heat of the reactant. So change, how can we find product minus reactant? So product is always greater here in the endothermic reactions. So then we can get the heat content is positive. Clear? Any doubt? Okay. Once briefly I'll explain so that now you finally can okay understand. So here we are going to we are dealing with some new word called as enthalpy. So this new enthalpy is a scientific word, but its meaning is very simple. That is heat content. Heat content means what? Which is equal to the amount of heat absorbed or amount of heat evolved, means released at a constant pressure. Okay, at a constant pressure, how much heat is absorbed or released is called as a heat content. So here this heat content, absolute heat content value cannot be calculated. Okay, but here we can calculate by using the formula already shown the formula, that is nothing but a sum of the internal energy and the product of the pressure and volume, right? So delta H is equal to delta E plus PV, P del V. Okay, by using that we can calculate. Okay, and what is about the delta H? Means heat content, that is enthalpy for endothermic and exothermic reactions. For exothermic reactions, here the heat content of the products is less than the heat content of the reactants. So therefore the enthalpy is taken as negative. Okay, in the endothermic reactions means what? In which the reaction takes place with the help of heat. Okay, by observing the heat. So here the product heat content is greater than the heat content of the reactant. So difference is what? Heat content of the product minus reactant. So that will be positive. Are you understood? So this is about this one. Okay. Now today's last topic is reversible and irreversible process. Students, here a reversible irreversible process means what? Generally, normally what you think, just imagine a reversible and an irreversible means what do you think? Just once say. So reversible means what? If the one object or something is converted into some other thing, for example, reactant is converted into product, again that product again it comes to the same stage, okay, can get back to the original shape, original state, then that is called the original object if you can get, then that's called reversible. Normally you can think like this, okay. In the school level you might have studied that reversible and irreversible. For example, you take the water, and this water if you keep in the refrigerator, so this becomes ice, right. So here liquid is converting into the ice, right. Now if I take the ice out of the freezer, then what happens? Again it become liquid, means what? This is a reversible. It is what? Reversible. So here it's going from solid to liquid to solid, again solid to liquid. For example, if you take the candle and you melt it, so on melting what happens? Candle turns into solid, right? Sorry, liquid. Again you cool it, again it becomes into the solid. So this is called reversible, generally you take, okay. Now irreversible is what? Generally what you learnt, for example, if you take one paper and if you burn the paper, that form an ash, okay. Can you make that ash again to the paper? No. So once it is changed. So that is called irreversible, right. So which cannot be irreversible, so it cannot be taken reverse, okay, that's called irreversible. But in the thermodynamic, the reversible and the irreversible have some little different meanings, students, little different meanings, okay. Little different meaning means what here? For example, a reversible means what? If one reactant is there, okay, and it is initial position, something initial, it is at initial position. Now it's the reaction is going on, and finally it goes to the final position, okay. Then what happens? Again after some time, this from final position to again it is coming to the initial position, okay, changing, reversible, okay, changing. So here if you see the path, it is in here, if you see the path, in which path the object, okay, is changing from initial to final position, again if it comes along with the same path means in the same conditions, okay, then we can say that reversible, okay. And irreversible means what? Irreversible means what? Here the content is changing, okay, but it may not be, it may come back again to its initial position, but it may not come back, okay, according to the same path. In which path it's gone, in the same path it may not come, okay, that is. So here, for example, students, here observe carefully, here we are taking two cylinders with a piston, okay. So this is cylinder and this is a piston, okay. So this is a piston. In this piston I will arrange one plate here, this is a plate, and here the gas molecules are there, here the gas molecules are there, these are the gas molecules, and they are pressed here by using some sand, you know the sand, okay. So I am taking some sand and I am placing the sand on it, okay. So these are all sand particles. All right, sand particles. These all are sand particles. Okay. Now what I do? Here I'll take one more cylinder. Okay. So this is a piston. Here also I put one plate, and I'll put only one big stone. One big stone. Okay. I'm putting one big stone. For example, you think. Okay. And here also there is a gas. Here also there is a gas, right. Now see students, here some weight means some sand here kept here, so it is exerting some force, pressure, okay. So due to this pressure, this gas, okay, till here this piston is occupying the space. Here also same, here I put some weight on it, so here also it's occupying this much, okay. So weight I kept, so that's what it went to down, so till here. Now for example, if I remove the weight, okay, for example you think like this, okay, so here it is a cylinder and till here is a gas is there and I kept one cylinder, sorry, piston, so this is a piston. If normal piston is there like this, the gas is up to here, the gas is up to here at this position the gas is there, right. Now if I apply the pressure on this one, if I apply the pressure, so what happens, normally it will go down, yes or no, it will go down. So like this, instead of applying pressure by my hand, I kept some weight here, okay. So I kept the weight here, so it went down till here, right. Now after applying the pressure, it went down. If I remove the pressure, then what happens, again it come back to original, right. So imagine that, now I kept the weight, now it is my initial stage, right. Now here one stone is there, I am removing the stone, When I remove the stone, then what happens, this piston will move up, okay, till here it will move, okay. So how much time it will take to move up? Suddenly it will take, when I am taking the weight, immediately the piston is coming up, okay. So this is a fast reaction, fast it is taking place, right. Now here you see, here this also same, first initially the gas volume up to till here, but as we kept the mass, it went down, as we kept the sand, due to it, it came down. If I remove the sand, it will go up, yes or no, right. Now what I do, here these are sand particles. If I take certain amount of sand, in that how many particles will be there? Some thousands of particles will be there, yes or no? Sand particles are very small. I am taking very large amount, this much amount of sand, I am keeping on this one, okay. So then what happens, here thousands of particles are there. So due to that weight, this piston is here. Now observe carefully, Now what I do, I will take one sand particle from here, only one sand particle from here, out of thousands are there, one particle I am taking. Does it move up or not? What is your answer? No. The answer is yes. It can move up, but how much it will move? Only little minute, we cannot observe. Okay, our eyes cannot able to observe, so that much small, because we have taken only one particle. So what happens? Slightly it may move up, very slightly it will move up. Okay, very slightly. Our eye cannot recognize that. Okay. Now you take one more particle, again it is slightly moving. So if you see, if you take one particle, if you see here, it looks like it is not moving. It's not moving. Okay, but it moves slightly, very slightly. Now slowly one by one, if you remove, finally when you make it empty, okay, all you remove, then you see that the piston will come here. Okay, but when you remove first one and see, you don't observe any change in that. Then you take second one, now also it's looking not changing. If you take the third one, now also it's not look like not changing. But actually it's changing very slowly, very minutely, okay, this one is changing, okay. So now, it's taking infinitesimally small way, okay, very slowly the path is going. So, which, okay, in such type of reaction, which the reaction or taking place, means from initial to final position, it's taking very slowly. So, such, okay, reactions are called as a reversible reaction. What they are called? Reversible. So, here if the sudden is taking, okay, if just this is because this is old one only. So, just I remove the stone, immediately goes up. If I put the stone, immediately comes down. So, I can only find what is initial position, what is final conditions. Final conditions and initial conditions only I can observe. Initial position and final position. For initial conditions and final conditions only I can observe, but I can't observe throughout this path. But here I can observe, okay, here also, here also, here also, here also, here also, here also. Everywhere I can observe what are the change in the conditions. Yes or no? So, such type of reactions are called reversible. So, reversible reactions are very slowly, infinitesimally slow. Infinite means what, you know? okay, long, okay, infinitesimally slowly. So once you check, students, here in your material, if you have in the page number 93 or 92, 92, you see, a process which occurs infinitesimally slowly, opposing the force of infinitesimally smaller than the driving force, okay, and it is said to be reversible process, okay. A reversible process is considered to proceed from initial to final stage through an infinite, okay, series and infinitesimally small stage. At every stage it is virtually in state of equilibrium, and a reversible process is an ideal process, okay, and it cannot be realized in practice. But now if you see the irreversible process, when the process goes from initial position to final position, okay, is in finite time. Finite time is what? Within a small time it will take place, and it cannot be reversed, and it is termed as a irreversible, okay. In such cases, state exists only initial and final stage of the process. So we can determine only initial stage process and final stage process, but in the middle of process what you are doing we can't say, because it's going very faster. Is this clear to you? So an irreversible process is spontaneous in nature. Spontaneous means immediately it will that spontaneous immediately, okay. So it is a real and performed in practice, and all natural processes are irreversible in nature. All natural processes what are taking place, they all are irreversible in nature, okay. So that's all, students. So with this we can complete, okay, we completed this topic, and here are some few questions are there. I hope you can do it. Okay, once comes and let's explore. You see the page number 94. The correct expression among the following: E is equal to H plus P, H is equal to E plus P. These are right answer. So second option is the correct one. Okay, H is equal to, just now I written, H is equal to E plus PV. Okay, so the option is second option. Right. Now then, in exothermic reaction, what is the exothermic reaction? Okay, this also we discussed. HR is greater than HP. So HR is greater than HP, or HP is less than HR. So option is 2. The reaction which proceeds with the evolution of heat, in with the reaction which heat is released, what is that? Exothermic. So the answer is 1. Heat change in the chemical reaction at constant temperature and pressure is called enthalpy. What is called? Enthalpy. We are discussing about enthalpy. The heat change associated with the reactions at constant volume is due to difference in the property. That's called enthalpy. So answer is 2. Regarding the thermochemical equation, the wrong statement. Okay, students. So with this, we stop. Remaining few questions out there. That few questions you can do it very easy. So first read the topic, content you read. After reading the content, you try to attempt the questions, so you can attempt very easily. Okay. If you have any doubt, we discuss in the next classes. Until, take care. Bye.